In our last module, we explored the challenge of separating signal from noise in our metrics. We learned why it's crucial to distinguish between normal variations and significant changes that deserve our attention. In this module, we will take that understanding further by exploring specific tools and techniques that help us make these distinctions systematically and reliably. Now, I know what some of you might be thinking. Isn't Statistical Process Control, or SPC, just for manufacturing? That's where it started, but companies like Amazon and Microsoft have adapted these techniques to improve their software development processes dramatically. At its core, SPC helps us understand when changes in our metrics deserve attention and when they're just normal variations, precisely the challenge we discussed in our last module. Every product team has experienced this challenge. Your metrics show a change, and you have to decide whether to investigate or wait and see. Without a systematic approach, teams often either waste resources chasing normal variations or miss early warnings of real problems. The cost isn't just the time spent in unnecessary investigations, it's also the opportunity cost of where that time could have been better spent. In this module, you'll learn how to implement SPC tools in your product development process, integrate them with agile practices, and most importantly, use them to make better decisions about your metrics. Statistical process control might have its roots in manufacturing, but its principles are incredibly valuable in software development. Amazon, for example, uses control charts to monitor service performance metrics in real time, allowing them to quickly detect anomalies and respond to potential issues before they impact customers. The key benefits of SPC and software development include reduced false alarms so your team stays focused on real issues, more consistent delivery through better process understanding, better resource allocation by knowing when to investigate and when to stay the course, and true data-driven decision-making rather than gut reactions to every metric change. SPC is particularly powerful because it builds on what we already know about variation in our metrics, but it also gives us specific tools to measure and monitor that variation systematically. Instead of debating whether a change is significant, we can use objective criteria to make that determination. Let's start with one of the most potent tools in SPC, control charts. If you use Jira for project management, you might have encountered these without realizing it. Both Scrum and Kanban boards in Jira include built-in control charts that track your team's cycle time, how long it takes work to move from start to completion. This isn't just a nice visualization, it's a powerful way to understand your team's performance and stability. Control charts do something crucial that regular metrics dashboards don't. They help us distinguish between normal variation and significant changes that require our attention. They establish control limits, boundaries that tell us when a change is outside what we'd expect from routine process variation. Let me show you how this reduces false alarms and improves resource allocation. Microsoft uses control charts to monitor their software telemetry data. Teams continue their planned work when a metric falls within their established control limits. But when a metric exceeds these limits, it automatically triggers an investigation. This systematic approach means teams spend time investigating only those issues that statistically deserve attention rather than reacting to every change. The real power comes from monitoring both input and outcome metrics. Let's say your outcome metric is weekly active users. A control chart for this metric tells you when your user engagement significantly deviates from standard patterns. But even more valuable are the control charts for your input metrics, the levers you can pull to influence that outcome. These might include application performance metrics, feature release frequency, bug rates, or marketing campaign engagement. By monitoring these input metrics with control charts, you can spot potential issues before they affect your outcome metrics. When an input metric goes outside its control limits, you can take corrective action before it impacts your users. Control limits differ from the targets or goals you might set for your metrics. While a target represents what you want to achieve, control limits help you understand what's normal for your current process. They're typically set at 3 standard deviations above and below your process average, which statistically captures 99.7% of normal variation. Let's make this concrete. Amazon's approach to monitoring service performance shows how this practice works in practice. When monitoring API response times, they establish control limits based on historical performance data. If response times typically average 200 milliseconds, with normal variation between 150 and 250 milliseconds, this becomes their baseline. Any responses outside these limits warrant investigation because they represent statistically abnormal behavior. But here's where many teams get tripped up. They confuse control limits with specification limits. Specification limits are what your business defines as acceptable performance. Your service level agreement, or SLA, might specify that all API responses must be under 300 milliseconds. That's your specification limit. Your control limits, however, tell you whether your current process can consistently meet that specification. This distinction matters because it helps you decide when and how to improve your process. If your control limits show that your normal process variation extends beyond your specification limits, you must improve the process, not just react to individual violations. Let me start with a simple example to show how input and outcome metrics work. Imagine a pizza restaurant is trying to decrease the time between when an order is placed and when a pizza is delivered. Their outcome metric, the thing that matters to customers, is how long it takes for a pizza to arrive at your door. But that outcome has some variables outside of the restaurant's control, so they focus on the things they can control, like how many delivery drivers they schedule per shift, the temperature they maintain in their ovens, how long they allow for dough preparation, and the routes they assign to drivers. Each of these inputs gets its own control chart with control limits. If dough prep time suddenly exceeds its upper control limit, that's a signal that something has changed. Maybe equipment needs maintenance or staff needs retraining. By monitoring these controllable inputs, the restaurant can spot and fix problems before they affect delivery times. Software teams work the same way. Let's look at how Google manages its search performance. Their key outcome metric is page load time, how long users wait to see their search results. Just like the pizza restaurant can't directly control delivery time, Google can't directly control page load time. Instead, they monitor input metrics their teams can control: the index freshness rate, or how often they crawl and update search data, JavaScript and CSS file sizes, the number of API calls per search, cache hit rate targets, and server capacity allocation. Each input metric gets its own control chart with its control limits. When an input metric goes outside its limits, it signals that something has changed in how the team executes. For example, if JavaScript file sizes suddenly increase beyond the upper control limit, it might indicate an issue with their code bundling processes or a problematic deployment. The power of monitoring both input and output metrics this way is twofold. First, it helps teams focus on what they can control, the specific technical decisions and processes that affect page load time. Second, when they do see shifts in their outcome metric, they can trace them back to specific changes in these controllable inputs. This makes troubleshooting more systematic and effective than reacting to slow page loads in isolation. It also means that the team can focus on leading indicators, such as the number of API calls made, instead of the lagging indicator of fewer users on Google.com. Statistical Process Control creates an early warning system focused on the levers teams can actually pull. By monitoring these controllable inputs through control charts, they can identify and address potential performance issues before users experience slow search results. Now, you might be wondering how all this fits with Agile development practices. After all, Agile is about responding to change, while SPC seems concentrated on maintaining stability. Successful teams have found these approaches complement each other perfectly by focusing on the right input metrics. Let's look at how Microsoft uses SPC to monitor the health of its continuous delivery pipeline. They track input metrics like build duration, test execution time, code coverage percentage, failed test ratio, and the time from commit to deployment. Each of these metrics has its own control chart with established limits. When a metric goes outside these limits, it signals a potential process issue that needs attention. For example, suppose the build duration suddenly exceeds its upper control limit. In that case, the team knows something has changed in their build process. Perhaps a new dependency is causing slowdowns or their test suite needs optimization. This approach helps teams distinguish between normal process variation and problems requiring intervention. Not every failed test or longer build time needs investigation, but when these metrics show sustained shifts outside their control limits, teams know they need to take action to maintain their agile delivery capabilities. The key is that SPC helps agile teams focus on process health rather than just output. By monitoring these input metrics, teams can identify and address issues before they impact their ability to deliver value for users. This proactive approach aligns perfectly with Agile's emphasis on continuous improvement while providing objective criteria for when to make process changes. Now, let's address something crucial that many teams overlook. You don't need everyone to become a statistician for SPC to work. In fact, SPC was initially designed to be used by factory workers with clipboards and minimal education. There's nothing complex about it. If someone could do it with a pencil and paper on a factory floor, your team can certainly do it with modern tools and automation. Here's what successful teams do. First, they establish regular review rhythms. This might be part of your sprint retrospective or a dedicated metrics review session. Consistency is important. Looking at your control charts should become as natural as checking your sprint burn down. Second, they focus on education before escalation. When a metric goes outside control limits, team members should understand what that means and what actions to take. The goal isn't complex statistics, but building a shared understanding of your process. Finally, they automate where possible. Tools like Jira's control charts or custom dashboards can flag when metrics exceed control limits, making it easier for teams to know when to investigate. What used to require manual calculations and plotting can now be done automatically, letting teams focus on interpreting the results rather than creating the charts. But having the right tools and understanding is only half the battle. Even the best SPC implementation will fail if teams don't build the proper habits and communication patterns around it. Let's examine how successful teams create a culture where SPC becomes part of their DNA. First, they establish clear review cadences. This isn't just about looking at charts, it's about bringing people together regularly to discuss what the metrics are telling them. These reviews need to happen on a consistent schedule, not just when there's a problem. Some teams include metric reviews in weekly staff meetings, while others schedule dedicated monthly deep dives. The key is making it a regular, expected part of the team's operations. Second, they invest in upfront education. You can't just throw control charts at people and expect them to understand what they mean. Before implementing SPC, successful teams ensure everyone understands what they're tracking, why they're tracking it, and how to interpret the results. This education needs to happen before you start using metrics for decision making. It's not something you can effectively do on the fly when issues arise. This isn't something you can spring on people. It needs to become part of your team's natural way of thinking about metrics. Finally, they make the data visible and accessible. Whether it's dashboards on team room monitors or automatic alerts in Slack channels, successful teams ensure everyone can see and understand their key metrics at any time. Microsoft's Azure DevOps team provides a great example of this approach. They display their key metric control charts on information radiators throughout their workspace. When metrics exceed control limits, they have clear protocols for who gets notified and what initial investigation steps to take. This systematic approach ensures that everyone knows their role in maintaining process health. One of the most critical lessons from companies that have successfully implemented SPC is to start small. Don't try to monitor everything at once. Instead, begin with one important outcome metric and its related input metrics. Let's say you start with your deployment success rate as your outcome metric. You might monitor these related input metrics: code coverage and automated tests, the number of failed tests in the CI/CD pipeline, code review completion time, and build duration. Focusing on a single process first can build team confidence in using SPC, establish your review and response procedures, and demonstrate value before expanding to other metrics. We started this module by asking whether changes in our metrics deserve attention or represent normal variation. Through statistical process control, we now have specific tools and approaches to answer this question systematically and reliably. Let's recap the key points. First, control charts give us an objective way to distinguish between normal variation and significant changes that require investigation. Whether using built-in tools like Jira's control charts or implementing your own, these visual tools help teams decide better when to act. Second, We create an early warning system by monitoring both input and outcome metrics. Rather than just reacting to problems after they affect our outcomes, we can spot and address issues in the input metrics we control. Third, SPC works hand in hand with agile practices. It's not about preventing all variation, it's about understanding which variations matter and require our attention. Most importantly, successful implementation isn't about complex statistics. It's about building team understanding, establishing consistent review practices, and starting small with metrics that matter most to your team's success. In our next module, we'll build on these measurement concepts by exploring two powerful frameworks, Hart and Hosker's. These frameworks ensure the metrics you track and analyze connect to user value and outcomes. You'll learn to combine quantitative data with qualitative insights to create a complete picture of your product's performance. As you leave this module, I encourage you to take that first step with SPC. Choose one important outcome metric for your team and identify the input metrics that influence it. Set up control charts for these metrics and begin monitoring them regularly. This foundation in statistical process control will help you make the most of the frameworks we'll explore next.